And we're going to go on to 5-3 a little bit today. All right, let's do this. So this first one, I have tangent to the fourth is equal to tangent squared, secant squared minus tangent squared. Again, we always try to pick the icky side first. So which side should we probably work with?
Right side.
The right side. What could we do to the right side? I don't want to go to sines and cosines right now. We don't have an identity yet. What can we do? Factor out a tangent squared. I like that better. All right, so let's factor out a tangent squared. And what are we left with? So now it's just secant squared minus 1. Now do you notice anything? Yeah. What is secant squared minus 1? Tangent squared. So now I have tangent squared times tangent squared, which is tangent to the fourth. And is that where we want to go? Yay. All right. Let's look at this next one. I have secant cubed. Cosine to the fourth is equal to cosine to the fourth minus cosine to the sixth quantity times sine x. So again, very similar to the first problem. What could we do? Okay, what do we do to the right side?
Take out a cosine to the fourth.
Let's factor out a cosine to the fourth. All right, and then what are we left with? 1 minus cosine squared. And then times sine x. Well, what in the world is 1 minus cosine squared? That's sine squared. So now this is sine squared, and we have sine x, and we have cosine to the fourth x. All right. Well, what happens? Sine squared and sine go to what? Sine cubed. So now we end up having sine cubed, cosine, x, and then cosine to the fourth x. Is that where we want to be? There we go. That's decent. All right, let's look at this next one. I have cosecant to the fourth, cotangent, is equal to cosecant squared times cotangent x plus cotangent cubed. Let's factor out a cotangent x. So now I end up having a cosecant squared times cotangent, and then times what? 1 plus cotangent squared. All right. And then what could we do?
Is that an identity?
That is an identity. What is it? That is just cosecant squared. So now I have cosecant squared, cotangent x, times cosecant squared x. And then what happens to those cosecant squareds? They become cosecant to the fourth. And then we still have cotangent. And we're there. All right. Pretty good in the hood. This thing. I said it wasn't going to go away. Yeah, it's back. All right, it's back. All right. So here we go. So when does sine x equal 1/2? At pi over 6. Is there any other time that it equals 1/2? At 5 pi over 6, right? But is that it? No. What if we add 2 pi to it? What would happen? I'd get 13 pi over 6, right? And so if 13 pi over 6, well, sine of 13 pi over 6 is also what? 1/2. So now we have to be worried about the periods. What's the period of sine? 2 pi. So that's why we have to say pi over 6 plus 2 in pi on it. And we have 5 pi over 6 plus 2 in pi on it, because it's going to equal 1/2 because it's a wave after wave. It slowly drifts. All right? Because it's coterminal to them. Okay? Does that make sense? All right? So why do we have to add 2 in pi to it? Because its period is 2 pi. All right? So we always... Sine x plus square root 2 is equal to negative sine x. So what I need to get is a trig function equal to a number. I need to get a trig function equal to a number. So let's figure out how we manipulate this. What could we do? Okay, subtract sine x. So now I have square root 2 is equal to what? Negative 2 sine x. Okay. Now what? I need to get a trig function equal to a number. So what do I need to do now? Divide by negative 2. Okay. So now I end up having sine x is equal to negative square root 2 over 2. And now we need to figure out, when does sine equal negative square root 2 over 2? Again, sine goes with who? X or y?
Y.
Y. So what two quadrants is this going to happen in? The 3 and the 4. All right, so they're going to happen there. So when does that happen? X equals what? 5 pi over 4 and 7 pi over 4. However, what do we need to add to it? Do I have any domain restrictions? No. So what do we need to add to it? Plus 2n pi. And plus 2n pi. Because if it goes around again, it will go there. All right? And one whole circle is 2 pi. Okay? All right. Here we go. So now I have 3 tangent squared x minus 1 is equal to 0. Again, I need to get a trig function equal to a number. A trig function equal to a number. So what could I do? Add 1, divide by 3. So now I have tangent squared is equal to 1/3. Now what? I don't have a trig function equal to a number yet. So what do I need to do? Not square it, but square root it. I need to square root it. And when I square root something, what happens? I get a plus or minus. All right. So now I have tangent x is equal to plus or minus square root 1 over 3. Well, I'm going to go ahead and distribute my square rooting. So I'm going to say it's like square root 1, which is what? 1. And so I really have like 1 over square root 3. And I'm okay if you leave it like that. Because really, what can we get from our unit circle? We can get a 1/2, we can get a square root 2 over 2, and we can get a square root 3 over 2, remember? So this is basically saying what? Not 1 over square root 3. This is really saying 1/2 over square root 3 over 2. And how do I want you to think of tangent? Y over x. I know we're going back to unit circle days. All right. So anyway, I want you to think of it as y over x. So when is my y 1/2 and my x square root 3 over 2? But I have my plus and minuses going on. At pi over 6. When else? 5 pi over 6. When else? 7 pi over 6. When else? 11 pi over 6. So my answers are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. However, I want to show you that we don't need all of them. First of all, what's the period of tangent?
Pi.
It's pi. All right, so what do we add to them? Not just pi, but plus n pi. All right, because it's an integer times pi. All right, and so if I add n pi to this, and I add n pi to this, I want to show you what happens. How far around the circle is just pi?
Half.
It's halfway. It's halfway. So if I have pi over 6 right here, if I go halfway, what did it get to? 7 pi over 6. So do I actually need this answer of 7 pi over 6 plus n pi? No, I don't need it. The way I think of it is it gets covered. That's the way I truly think of it. It gets covered by the pi over 6 plus n pi. What else would get covered then? 11 pi over 6. Because if I add pi to 5 pi over 6, it gets to what? 11 pi over 6. We don't need that anymore because it gets covered. You following me? All right. Tangent. X cosine squared x is equal to 2 cotangent x. Everybody wants to divide by cotangent x, and I understand why you want to. However, if you divide by it, you get rid of it. Okay? And we truly don't want to get rid of it. We're going to be setting things equal to 0. All right? So I'm actually going to kind of guide you on this one. We're going to subtract 2 cotangent x. All right? I understand why you wanted to. However, you'd have no solutions if you did that. So we're gonna subtract. Okay, we don't want to actually get rid of these things because then we're not working with the original equation. Okay, but I totally understand why you want to do that. Now what could we do?
Factor out a cotangent.
We could factor out a cotangent. Good. All right, so if we factor out a cotangent, what are we left with? Cosine squared x minus 2. Now, just like you did in Algebra 1 and all those things before, you set each one of these equal to 0. All right, the zero product property tells us to do that. So now I have cotangent x is equal to 0, and cosine squared x minus 2 is equal to 0. So when is cotangent equal to 0? Remember, how do we think of cotangent? X over y, right? So when does cotangent equal 0? When is my x 0 and my y something other than 0? At pi over 2 and 3 pi over 2. Well, what's my period of cotangent? Pi. So if I add n pi to it, do I need both of these? No. Because pi over 2 plus n pi was what? 3 pi over 2. So I don't actually need this one. Are you following me? All right, let's look at this next one. So now I have cosine squared x minus 2 is equal to 0. So I need to get the trig function equal to a number. So how do I do it? I add 2. Then what? Then I square root it. So then I get cosine x is equal to what? Plus or minus square root 2. So when on my unit circle does cosine give me a plus or minus square root 2? I know you're having trouble with this, aren't you? It doesn't. Why doesn't it? What?
If you have the tangent or cotangent, it's 1. And then with any of the other ones, it's pi over 2. Or square root 2 over 2.
Okay. But why can't cosine be square root 2? Okay, it doesn't have to necessarily be on the unit circle. But what's the range of cosine? -1 to 1. Is square root 2 bigger than 1?
Yes.
Yes. All right. So that's why this thing doesn't exist. All right. So we don't actually have a solution on that. So what's my only solution? Pi over 2 plus n pi. All right. Those are my only solutions on it. All right. Pretty good?
Yeah.
All right. Here we go. 64. Which side should I work with? Let's work with the right side. So what could we do to it?
Take out cosine.
We can't actually take out a cosine because 1 doesn't have a cosine. So we can't actually factor something out on all my terms.
Take out a 1.
Factor it.
We're going to factor soon. This is the way I'd like you to do it. How many cosine to the fourths do you have? You have 2 of them. So we're going to split that up. So now I'm going to say it's 1 minus 2 cosine squared plus cosine to the 4th x, and then plus cosine to the 4th x. Because I really want one of the cosine to the 4th x alone. You following me? So now I'm going to kind of regroup these. I kind of want to work with these now. Well, what could I do with that? I could factor that. Exactly. You can kind of think of this as like 1 minus 2x plus x squared. But instead of x, it's cosine squared. Well, what could you factor this 1 minus 2x plus x squared to? What does that factor to? It's actually 1 minus x and then 1 minus x. All right. So, what would this factor to then? 1 minus cosine squared x, and then 1 minus cosine squared x. Well, did you notice anything yet? 1 minus cosine squared is actually what? Sine squared. So now I have sine squared times sine squared. And what is sine squared times sine squared? Sine to the fourth. So now I have sine to the fourth x plus cosine to the fourth x. And we're there. All right.